Section 4, example 29, integrating an odd function. So evaluate the definite integral of the odd function from -5 sine x over the interval from -pi to pi. So we're just going to integrate like normal and we'll see what happens. All right, so from -pi to pi, we're integrating -pi to pi. Sine, what do we say? Sine x dx. All right, so integrating sine, it's going to be cosine x, going to be negative cosine because the derivative of cosine is negative sine, so we have to make sure that it's negative there. And we're going to evaluate this from -pi up to pi. So negative, we have cosine pi minus cosine of -pi. All right, cosine of pi. So pi is over here. So cosine of pi is over here. Cosine of pi is -1 minus cosine of -pi, exact same place. So that's going to be -1 as well. Oh, and actually this was -5. So let me fix this really quick. -5. That's times -5, which would make this out here +5. Might not change it much, but who knows? All right, so there's that. 5 times -1 plus, so the area is 0, but I feel like I know that the area shouldn't be 0 itself, right? Let's graph this just to make sure. Maybe I'm wrong, maybe I'm not wrong. All right, so going from -pi up to pi. So normally sine graph comes up this way and down this way, but because it's negative, it's going to go down. So we'll say down this way, which means it comes up this way. Amplitude 5, -5 here. Oh, I see. So up here we have a positive area. Down here we have this negative area. So when we integrated between those two areas, we ended up with 0 because they're exactly the same there. So an odd function is going to have an area of 0 unless you break it up where it's like broken up. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.